Hello, everyone. My name is Gitika Gorthy, and today I am very honored to be interviewing a very special space champion, Professor Ju, who is currently a professor at Princeton University. Professor Ju received his bachelor's degree in engineering thermophysics from Tsinghua University in 1986 and his Ph.D. degree in mechanical and aerospace engineering from Tohoku University in 1994. He is a Robert Porter Patterson Professor in Mechanical and Aerospace Engineering and serves as the Director of Sustainable Energy Program. Professor Ju's research interests include combustion, fuels, and low carbon energy conversion in the areas of near limit and supercritical combustion, plasma assisted combustion, and chemical manufacturing, alternative fuels, chemical kinetics, and energy materials. So you can see he is all over the place and has such great interests. He has published more than 250 journal articles. He is a fellow of ASME and a fellow of the Combustion Institute and serves on the board of directors of the Combustion Institute and the Institute for Dynamics of Explosions and Reactive Systems. Professor Ju has also received many awards, including the Distinguished Paper Award from the International Symposium on Combustion, the NASA Director Certificate of Appreciation Award, the Friedrich Wilhelm Bessel Research Award by the Alexander von Humboldt Foundation, the International Prize from Japanese Combustion Society, and a plenary lecturer of the 38th International Symposium on Combustion. He is such an amazing space champion with a heavy research background that I can't wait to learn more about. Welcome, Professor Jude. Thank you so much for taking some time out of your busy schedule to do this interview.
Thank you, Gitika, for giving me the opportunity. Thank you. My pleasure.
Yeah, I'm really excited to learn more about your journey and how you really got into the space industry in more depth. But before we get started, I'd like to know more about your typical day. What do you currently do and how does it run?
My research right now, as you can see, that there is combustion and propulsion. From combustion side, we try to develop a sustainable fuel, biofuel, or alternative fuel to reduce carbon. And from propulsion point of view, that we want to improve the efficiency, reduce the carbon emissions, and to develop, for example, supersonic or hypersonic vehicles and rocket fuels, for example, gas turbine combustions. So these are the core part of combustion and propulsion. And I also get interested into that future in terms of low carbon energy conversion, particularly that when we address that the climate issue, we have to reduce the carbon from burning fossil fuel. But the United States is a wonderful resources of fossil fuel. So what we can do, we could using renewable electricity integrated with, for example, photons or lasers or plasmas that can convert, for example, fossil fuel, CO2 and biomass into carbon materials, which we need, and also hydrogen, and using hydrogen to power electricity, power turbine in the future. I'm also interested in developing this cathode materials for electric vehicles to make it safer and higher energy density. So these are the interests and of my research, and I have 12 to 13 research staff and students around me. So it's very exciting.
Yeah, that sounds definitely exciting. Probably busy all the time with your research. And has the pandemic impacted your research?
Yeah, I think that the biggest impact is that you really that you cannot travel and you cannot meet your colleagues to exchange ideas, right? That is really depressing. And if as a researcher, and communication, collaboration is a highest value of research. And the second thing that because that the restriction of lab access and some of the computational research you can go online, but experimental research you have to be restricted at the one room, for example, one person, and that causing some delay of research, obviously. But during that the pandemic in May, I realized that how important it is to communicate with our colleagues. So I organized a combustion webinar weekly, every week, Saturday from 10 to 11. So international researchers, they come together through Zoom. They discuss what are the important findings and what are the interesting topic. And then we got, several hundred to people to participate that our webinar and on Saturday. and all the result will be, posted on the YouTube channel. So a lot of people are watching.
Yeah, that's amazing. I'm glad that you're able to, even in a pandemic, find new and creative ways to collaborate, meet with researchers, and inform.
Yeah.
So I'm really curious. Yeah, you've been a part of so many research projects. So what is the most exciting research that you've worked on or are working on?
So I think that there are a number of them. I think that I just give you example. For example, everybody know that the combustion is a fire, right? And understanding of the fire is a history of mankind civilization, right? So give you example, if you have a candle flame, so if you touch it and you will burn your fingers, and don't do that. And because that the flames normally is uh, you know maybe 2000 Kelvin, okay, very hot.
Yeah.
And then the candle flame, you look at it, is really yellow. So yellow because that the fuel, when they run into 2000 Kelvin, the fuel molecules basically break down. They form a lot of soot and carbon. So that soot carbon make you very yellow. And so that in order to reduce that emissions from carbon emission from combustion, you really have to burn that the flame at very low temperature, very very low, so that the carbon molecule will not break down, and so therefore you don't have soot or you have less NOx. So the exciting thing is we discovered that in last since 2013, and we discovered that in the nature, not only you have this a very high temperature, hot flames like candle flames, but also you have something called only a few hundred Kelvin. It's called cool flames, and also between the cool flame and the hot flame, there's something I call warm flame. By using some kind of chemical control in the laboratory, and we are very proud that we can stabilize these two kinds of flames. So interesting. It opened a new area in terms of combustion. Be helpful to control that the internal combustion engines. So that's one thing. Another thing that's exciting that we try to, using that the plasmas. The plasma is just like a mercury lamp, right? So there, the electron energy is very high, but the gas temperature is very cool, and you still touch the fluorescent light bulb is still okay. But if you using the high energy electrons in this kind of plasma, you can control combustion very well. For example, today a lot of people try to develop this you call detonation, rotational detonation engines to achieve 30% more efficiency, and but it's difficult to stabilize the detonation. So, but using a plasma and high energy electrons injected into the mixture, you can stabilize the detonation, and then you can make it um, stable and for better efficiency. And last one, right? And I try these days. I try to use, for example, you can using renewable electricity and to control plasma and then convert hydrocarbons into hydrogen and carbon nanotubes. For example, you can convert methane into hydrogen, and then the carbon in the methane can become a carbon nanotube. It can be used for industry materials, can be used in the electrode materials for lithium-ion batteries. There are so many exciting things, and is happening. And before, people in chemical engineering, people only know using something called equilibrium control. I mean, high temperature, high pressure, very long time. But today, that with this uh, plasmas and electrons, you can run chemical manufacturing without equilibrium. So that make it a higher efficiency, more selectivity. Is very exciting, and coupled with renewable electricity, because renewable electricity is very difficult to be stored, but you can using that renewable electricity at the peak hours to do chemical manufacturing. That is kind of energy storage and renewable electricity peak adjusting. So it's a wonderful opportunity.
Yeah, that sounds so cool. I think that's what is so exciting about research is when you make these small discoveries and being able to experiment with it is just awesome. I'm so glad you share this with us.
Yeah,
So
research is try to discover the nature, right? The beauty
yeah,
of the nature.
yeah,
And
definitely.
so engineering is try to do control the thing, make something, uh, nature doesn't have it, right? So that's the engineering. That both sides are exciting. And then one side is the beauty of the nature. Just like you go to Mars, you find something that is like you find the nature, something is beautiful. The other side, engineering, that is innovation. You're right. So it's like iPhone, rockets, and these are all innovations. They may not be, uh, you know, discovered in nature, but it make something nature never provided you, right?
That was beautifully said. I think that's the beauty of, I think, engineering, or research is, first of all, discovering the beautiful things Earth has and the world has, but also being able to, have man-made structures, and man-made, different elements that are man-made. I think it's really cool to see how we're able to, put a twist on the things that nature has provided us.
Yeah. Thank
And
you.
you have published more than, like I mentioned earlier, you've published more than 250 referee journal articles. So,
Yeah.
how do you conduct or are a part of so much research and work collaboratively with other scientists, students, and engineers?
I think the research is to publish your findings, right? And if you have you know, creative ideas, you can publish quickly than others, right? And also that if you collaborate with other people and in the field, and there's very limited thing you can do just by yourself, and you have to collaborate with the top scientists. For me, I collaborate people in Europe, people in national labs, and for example, Sandia national laboratories and Air Force research laboratories, and using their facility to do something we cannot do here. And we try to, and at Princeton, the important thing is that you to figure out creativity, right? Create some kind of innovative idea. Then you can collaborate with others using their facility or their tools to advance the understanding we want to be. So that's the way we can, publish more and sometimes stand in the frontier of research.
Yeah, discover more by working together collaboratively, and using both resources and getting the best out of what you have, and making use of the various facilities in universities or other facilities or other research centers, even across the world, is obviously that's the best way to get the best research.
Exactly.
So that, yeah, leads me to my next question is, you studied in China for your bachelor's degree and PhD before coming to America. And so I've wondered, in your journey, has America helped you further your dreams, the way you expected, or what was your transition like coming from China to America?
Great question. I think that I come to America uh, because I want to see the outside world, and I want to learn that the Western culture in terms of research. So I left China when it was the 1990s. At that time, China was really far behind in terms of research, and we have little knowledge about the outside world. So I went to Japan for my PhD, and actually I spent probably 3 years and finished my PhD there. And I become a teacher and professor in Japan. And I thought that I need to do, to go back to China to contribute something what I learned. So I went back to China for 1 year, and then later I figured out that there's something more important that I should do, which is I want to go to United States. That country I never been there, and I don't know that maybe I can, uh, do better. Okay, maybe I can learn more. And so I admired a lot about that U.S. institutions like Princeton, MIT, and Stanford, and these are Harvard. These are wonderful universities. So my dream and is that to come to have experience of working in this university. So that's how that it brought me to Princeton. So in terms of a difference, I think that the education and the research uh, between China, Japan, and the United States, a lot of difference. And if you think about the education itself, and put the research aside, education, and today I understand that education has three functions. One is that you pass the knowledge from the teacher to student. And second thing is that you think about creativity. You critically you think about you are forming a different opinion to think about it independently and critically. So that is a critical part of education as well. And the third part is really that it is a passion. You have to pass the passion to the student, make the student have their own dream and do something that they like to do in their career, right? I'm not afraid of failure, and then so that are the three functions I understand and for education. But China, for example, very good in terms of passing knowledge from teachers to students. The student quality in terms of mathematics, physics, and all this kind of learning, I don't see anywhere in Japan, the United States can be compared with those qualities of depth. And but China is not a culture to encourage that critical thinking. You pretty much encourage you to follow, respect. Whatever teacher says, you just say, okay. If you just understand it, respect it. If you don't understand, that's your problem. You have to figure it out. U.S. is different. That they want to say that if I say to interview you, and if you ask me today, and you may want to figure out, well, what is that correct? Is that the right thing? And you, even Professor Jew says so. So I think that is what the U.S. The U.S. so many talented people, and the U.S. has a very open society, right? Everybody is not, put you in a ladder that you are ranked, from the bottom to the top. Everybody has your turn, have your opportunity if you have creative ideas, if you have the courage to do something new. So that is different from China. And in
Yeah.
terms of yeah, in terms of passion, and I think that the U.S. is way better than China because that is the spirit of exploration. And if you look at that aerospace and or astronautics and the United States, right? You can people, has so much passion and so much dream. They want to go to Mars. They want to go to out of solar system. So I think that there's a clear difference in terms of education between China and the United States. The United States certainly do well in terms of critical thinking, in terms of passion. Uh, and China doing better. I think that is pass the knowledge that provide you math and physical skills.
Yeah, I mean, my parents both studied in India before they coming here, and they say the same thing. They say because they've seen both education systems, and it's something similar to what you were describing. So I
Mm-hmm.
think a lot of immigrants can relate with that. And you were mentioning how they had a lot of good knowledge transfer. So I'm also curious because you're also a professor here. Do you believe that there are the same space education opportunities in China as there is in America, or do you think that America provides you a lot more opportunities?
I think that today, I think that we're talking about the 2021 in terms of education. I think that probably China is doing better than United States in undergraduate education. So that's what I try to say. Very much a lower cost, probably so more quality of teaching and in terms of school. But in terms of research, I think the United States is doing better than China, way better than China. So that's a different thing. I think that, yeah,
Everyone has their positives and everyone has their negatives, I
but
believe.
that's
Yeah.
why that's why United States is great. You need a different talent, right? And the people like me, we come from China, and like your parents, you come from India. So this country take that the advantage that and absorb talents from other country and then and form different skills for innovation, right?
Yeah. Yeah. I think that's what makes America America. So,
Yeah.
did you always imagine yourself in the position you are in today? Or did you have some twists and turns in who you became?
You know, to be honest, that when I was, in college, I, um, I probably didn't want to be a professor. I want to be going into it, and I wanted to be a engineer. I want to be at industry. So, but as I took my PhD, and this is like the boat you got on, you have nowhere nowhere to go. And my advisor, and he studied, he studied in the United States and later went back to Japan. He talked to me a lot about this, history, about the science, about his advisor and his advisor's friend. That got me so fascinated. I want to know that the history in my field and what they're giants. I want to meet them. I want to have a chance to talk to them. And it got me more and more interested. And then we have a lot of course, during the research, you discover the beauty of nature, and then you have some kind of innovative thinking. And then you got more attractive, and then you become a professor. I didn't know that I will be United States, but I thought that after finishing my PhD, I'm pretty clear my career will be a professor somewhere. This is something, a position I wanted to take. After I came to Princeton, I thought this is the best place I want to be. I don't want to leave. And after I got here,
Yeah, that's amazing. So when you were younger, did you always want to go into the engineering track, or was that also you changed halfway?
and at my time, really, that is in China was my time. That it was the 1980s, right? If you can get into college, that's tremendous. It's extremely difficult. So you probably only a few percent of people can get into college that time. So whatever engineering or whatever you can get in, that is would be great. But for me, my study was okay, so I had some freedom to choose, and I like that the mechanics, the rocket firing, there's all
Yeah.
airplanes, they're all because of mechanics. So I started to say, oh, well, I want to study mechanical engineering. That's how I landed, at in this field.
Yeah, I think rockets excites everyone. That's really, what got me into space as well. I think every little kid is always they see those rockets go up and they're like, I want to do something in the space industry. So I'm glad to hear that that was your inspiration as
Mm.
well.
Yeah.
So yeah, traveling from China to Japan, becoming a professor here at Princeton, I'm sure there were obstacles in pursuing your passion. And, did you have some major obstacles that kind of maybe hindered your way or kind of set you back a little bit? And if so, how did you overcome them?
I think that uh, any country, a new country, and you go, and it's not going to be easy to to get a better position you want to be. And for example, Japan is quite a conservative society, right? So I mean, you come to Japan, you are foreigners, no matter what, you are foreigners forever. And even even you are a professor for 10 years, your student always knock your door. You say, "Hey, Professor Ju, when do you go back to your country?" Right? So that's kind of culture. But you have to tolerate, and then you have to you have to work with them. I think that one thing I remember, no matter where you are, and no matter what kind of job you do, in the end of the day, and it really depends on two things, right? One is your skill, right? Two is that there are always some important people who can help you when the chance comes. So that is extremely important. The second one, equally important as your skill. And so I was in Japan, and my advisor, who studied in the U.S., he told me a lot about the story about the United States, and that made me very fascinated, and also that he introduced me to his friend when his friend visited Japan. So then I got a chance to talk to them. So imagine that I told my advisor that I want to my thesis not in Japanese. I want to be in English so that the American scientists can understand it. So then I wrote my thesis. I sent it to my advisor's friend, who is a very famous professor in UC San Diego, and he liked my thesis. He wrote my letter. I want a job in the United States. He was the one was willing to write me a letter, and you find a famous person to write a letter that is the 40% and 50% success of your career already. And later I found that at every step for me to be promoted and in my career, and this gentleman wrote me a you know strong letters to support me. So one thing this is not just, and after I come to United States, it was so difficult. I couldn't speak English because I studied a little bit English when I was in China. Then I went to Japan. I spoke Japanese. I totally completely forgot my English. So the first 2 years was extremely difficult for teaching, and I can, you know, teach in a way that I understand. But when student raised a question, I could not understand what the question was. That's number one. And number two is challenge that when you come to United States is like you have to write proposals, get research funds, and the United States is different. That the proposals you have to call the program managers to talk to them to explain your ideas. That was like a terrible thing for me to,
Yeah.
to do. And they always ask me, who is the advisor? My advisor is a Japanese person. They don't know. Okay, forget about it. So I think that is very difficult in the beginning. But I think that the one thing in America is great is that people are so tolerant and so in the beginning, so the people in my department, the department chairs and also the senior professor, they are so tolerant. They just encourage me that, don't worry, we only judge you by your creativity. We don't judge you by money, and we believe you can teach better in the future. So I really appreciate that kind of tolerance, that kind of forward thinking, encouragement. And that for me, I learned that. That's the way I tell my younger colleagues now in the department. I said, okay, don't worry about the funding. Build your scholarship and increase your creativity, and we will judge you by that. And so that's you know that I said. Two things are important. One, it is that your skill. Second, it is that uh, there are some great people around you. They are all ready to help you. Don't miss that opportunity. All right.
Yeah, I think that's amazing advice. I think always coming to it from a different country is difficult, and seeing how you were able to push through that. And there was like a support system, there for you at your school, and your colleagues were always there to support and boost you. And building that network and those connections and relations is really important.
Yeah.
And I'm so glad you were able to, come out of that and, coming from a different country, understanding the English and being able to, catch up almost with the culture here is it's just very inspirational.
Yeah. Yeah. We have. I think that I appreciate American culture. I see that it's an open society and is very tolerant to I think that this is something America should continue in that way, and don't try to expel that the foreigners. You go back to your country, and that's the end of America.
Yeah, yeah, definitely. And
Yeah.
I'm also really curious more on going back to the space side. Was there like, or like in the beginning of your career stages, was there like a mentorship, an internship, or a volunteer role that helped you achieve your, dreams?
No, I that yeah. Today, I mean, America is very different, and so when I was uh, my time, that you really didn't have any opportunity for internship. But I think the only thing you look at is that your advisor, right, and his friends. That is a big window, and you look through that window, and he connects to the rest of the world. I think that the important thing is to when we were young, that is was that to say who is your role model, right? What kind of person do you want to be? So once you have that kind of idea, and you should set a goal that okay, I want to be that kind of person, right? You compare yourself to somebody is maybe 10 years or maybe 20 years above you. So and that this person is so successful, or that person is doing something very interesting, and you want to be something like that. I look at his legacy and understand that how he or she becomes so successful, and hopefully that you can build a relation with them, and that is really and important, and to follow the giant, right? When Newton says that they stand on the shoulders of giants, and we are not saying that you have the opportunity always to stand on the shoulder of giants, but you can follow them. These days, internet is so open, right? You can find that who is the role model. So that
Yeah.
inspired me.
Yeah, and I'm curious, who was your role model? I mean, growing up, I'm sure you've had someone in your life you looked up to.
Yeah, that's what is academics, right? I think that the person who wrote me a letter is some
Yeah,
kind of the role model for me to follow. If the one day if I could become like that, I know I would be great. So that's something I'm still working hard to be,
yeah,
that kind of person. But at least I have that kind of dream to be.
yeah. I personally look up to you. I think your successes so far are so, inspirational and successful in their own right, I believe. And so I'm also very, trying to, I really, your journey was so interesting to hear, but I'm also really excited to hear about what excites you and what makes you nervous about the space industry.
So what excites me, I think that space industry is that you got so many opportunities, right? And then not only you go to Earth orbit, you can go to Mars, you can go to beyond, and to explore that the space. It's so fascinating, and it's not about the business. It's really that you have a dream and you want to explore the unknown world, right? So that is really exploration. It's so fascinating. Frustrating was I saw that particularly I see for several years and then probably after I arrived in the United States, I was frustrating because that the U.S. government funding, research funding in space is really deteriorate. And for until 2012, I think that I would say that 12 years after I came to the United States, it was so depressing when you teach that the rockets and supersonic propulsion, because the United States has a very little funding in this area, and the rest of the country, for example, Japan, China, and India is doing extremely well. I mean, every year when you teach it, you basically say, okay, this is that is what other countries are doing. And United States basically had to rely on Russia to send our cargoes and astronauts to space for many years until SpaceX and Blue Origin came in, and that created an unprecedented opportunity for innovation in terms of rocketry. So that is, yeah, I tell you, the one is that is frustrating. The other one is that is exciting. So
Yeah, definitely. I think the startup of, private companies like SpaceX and Blue Origin and other like Lockheed Martin have really helped, further space missions and space exploration, which everyone's so excited about space these days with so many missions happening all the time.
yeah,
And so to wrap up, oh, sorry, go ahead.
go ahead.
Oh,
One thing I want to say is okay that private company is much more innovative than a
yeah,
government. You know,
yeah,
government can do something that private company probably have no interest or cannot do it. But if private company can do it, let the private company do it. They are more creative, more efficient, and more innovative.
yeah. I 100% agree. And to
Yeah.
kind of wrap up the interview, what advice do you have for young people regarding their pursuit of a passion in the STEM field or the space industry specifically? Something that you wish you knew when you were, a younger student?
I think that today that is society very different from what I was. I think that today that you have to have a passion, and the second thing that you are willing to take a risk, right? When you are young, and if something wrong, you can always change. You still have time. And the third thing that you want to, before you do something, you try to take an internship, either the university, let's say if you go to Jet Propulsion Laboratory, JPL, and why not take the opportunity to intern there? If you want to do research, let's say at Princeton or MIT, you can take a summer internship. You go to NASA, you can take an internship, take a look at it to see that whether this is something you really like to do, inspire you. So I think that are very important, and make a decision, and are not afraid to fail.
I think that's amazing advice to wrap up our interview with. I think the concept of not being afraid of failure and stick with something once you pick it, explore the options before you finalize. Make sure that's really what you're passionate about and you love to do. And I think that's so important for all of us to remember. So I want to thank you so much, Professor
Thank you
Ju,
very much, and
for being, yeah.
Jessica, thank you for interviewing me, and my great pleasure. Thank you very much.
Thank you. It was so
Okay,
inspirational talking with
good,
you.
good night.
Bye.
Good evening. Bye bye.